back. From this video, we continue on this Joe Concordo's book, Mastering OpenSCAD. We will move to the number 7 project called the Flame Sculpture. So in the right is the book, and you can come to project 7. This project aiming is not only the OpenSCAD can do some geometry design for the technical system which we did on the past project, but also they can do some organic shape. So this one is normally not like our technical one, but we try to simulate the flame, the sculpture. So it just to show you how the flexibility of OpenSCAD and the potential of its design capability. As usual, in the GitHub, I already have the earlier 6 project, and then we will have the starting to have this number 7. So here we will make the number 7 project file and store there. So let's start. I already opened the OpenSCAD and saved the first project name. So let me save as and go to the folder, OpenSCAD master number 7. Let's see what's the, just give our 07 flame sculpture. (01). So we're starting right away. So as mentioned by the author, we will start to have all the parameters all together to be defined first. So let's make, so first the program is the flame sculpture. And we have our module called the flames. Here is our parameter and the main program for the module. And then without we are putting those parameters, let's call that flames 180. We gave some code. So 1 is a circle, D equal to 60, dollar smoothness, it gave a 30 face, and this, do this. Let's have a look. Too many unnamed argument supplied. Flames, we don't have any flames. And then sphere, we need to define those D equal to 60. So those cannot run, I believe. And then let's starting to give some parameter, height. So that is the first one. So if we call this height, so height is, we don't have this height number. So let's see what's the height. We only gave our D. So that's the 2D. So that means we have nothing can show it, and the scaling. I pause and this I can copy this. So now we have all these parameters put in here. But so far, there's nothing can show because we still has not enough perimeter. But let's save this for now. That is our base program. Let's make the 2002. We're starting to give some figures. So all the perimeter, we have the scaling start end. So that means it's from the bottom to top. We have the different scaling. Then you can see that it's from bigger to smaller. And we have the radius, x and y, steepness. So later we will use this part and the transition, height, distortion, turns, whether it's turn or not, and slice, number of those slices. So in this number 2, we're starting to give some actual the program here. So that's the first one, is the positions along the path. So position. So we define increments is based on the height divided by numbers of the slice, and the rotation increase. So rot inc is based on the angle 360 turns. Turns now is 1, so it's no change. So slice is 30. So we have this one. Then we can use this definition to calculate our 3-dimension vector. So this is based on a 4 I equal to 0. Step is 1. Then we can ignore that or hide those. So my style is whenever you have the left curly braces, just immediately write the closed curly braces. So that is ensure you can prevent some potential error. So then after you have this pair, you move your cursor in the middle, then press enter, then ensure they are in the one set of those braces. So that's most of the time is coming the arrow for the reason. So rotation increase times x radius. That is x, and then it's a sine times rot inc times y radius. So I gave enough space, and z I divided by slices, height, distortion, yeah, times height. Remember here is yeah, I am wrong, so it should not be the curly braces. It's this one. Okay, now we have our the number 2. So we still cannot do these flames because it's not enough these cooling parts. But this is our second one. Let's keep saving. Let's go to the third one. So this one is just to give you some explanation on this effect of this height distortion. So now we give default is 0.7. So if it's 0.5, it's on this shape. 1 is just in the line, linear. But if more than 1 is from the bottom, it's slower go to the top. So that's the different effects for this perimeter. So let's continue. So all these perimeter are still kept. We don't have more things. So we already have this position. defined, and let's go to the second one, scaling along the path. So this is a function. Function sigmoid is named like that shape. So it's organic. We give a steepness. It's on the half of one transition. It's at 0.5. This equal to let increment equal to 1.0 minus tau thickness 0.1, and the starting point is our already defined perimeter. Is transition increment, and let this is our let, and this is 1, this is 1. So here we have this, but I have a question about this. Here is a 3. 1, 2, 3. Are we having one more? This brackets. Let's have just copy this to see the arrow or not. And I will also get this one. So we have defined our factor. So this factor is not in the function. So because this is our variable use, what we have done for this sigmoid. So until now, there's no arrow. So let's save and continue. It's already saved, I think. So far we cannot see any effects, but let's continue because we need to later on try to utilize this as soon as possible. So we have our scaling. Now let's do our first single flame. We need to start to draw that. That is 1 unit of flame. And then is our target is we build several flame. So for I equal to 1 to slice. Slices is 3, 0. We have the step of 1. So I and then we have the children 0. So let's try to see what we will do. So scaling, and after that we will call flame children 0. This for debug purpose. Okay, now we have our the circle and the sphere. If we don't have this sphere, shall we see the circle? No, the circle has no. So we have this sphere, let's define the inside 4. I think we should put that inside. So based on these children, let's start to do the transformation. So we made this from bottom to up. Then we can see the effect. So first we give our scale. Starting point. Scaling start. Oh, that I think I may put in wrong. Oh, starting point. That is correct. That is our different variable. Factors I plus scaling end times 1.0 minus f factors I. So we have this one. So you can see it's getting smaller. It's make those this kind of scaling, and then we do this linear extrude to height equal to 2. Now we give our height. So say this should be on this Z. So you can see now it's getting thicker. So the top one, we will do the translate. Translate means we will make that into some not in the center. So translate, then we're starting to have this the trees go to this path. So translate positions I. So I is 3 the 3 0. So whenever when we have this translate, is translate every time for this one, and then to go to the top. So let's see here, positions I. Let's have a look. I slices. Let's we got some error, but it's coming from this translate. So let's look at the error. From this 42. So linear. Why is missing one sentence now? Okay, good. Let's see here. So that is what we get. This one. So if we're coming from, I think it's is this from X and this from another direction. So you can look at. So but we are missing the bottom one. That is interesting. So let me double check. Is there any missing calculation? Children 0, flame children 0. So its code is 0 factor 1.0 deduct by this. This is time. I from 1. That's correct. But where is the bottom one? So 11. Let's back to here. So whether this I have some S factor for I slices 1.0 divided by this steepness transition is correct. And let's see this formula. transition steepening is both 0.5 or 1.0 power. This one time power is 0.5, 0.1. Starting point is minus transition increment 1 time 1 divided by E plus EXP minus this correct. Moving on, note is this term for X for I root Y slice distortion height. I think it is due to here. I should have. So that's the point is here should starting from this one, from 0. I from 0, then I have this bottom one. Let me make our screenshot. So then that's our interesting part. So here is 1. But in my code, I should put that in 0. I can have this one. Otherwise, it is disappear. So I save this, and I hope I report to the author and then to see. But through this a little adjustment, I think we have this expected shape now. So that is our number 4. We stop on here and continue from next video for the rest of the parts. Thank you for watching.